Okay, I'm going to talk briefly about confidence intervals and what they mean. Confidence intervals are not measures of variability. What they are there for is to give us an idea of the difference between the sample mean and a parameter mean. A parameter mean is the population mean. Remember that when we're doing research, we're not actually talking about the entire population. We're making an estimate of the population based upon our sample. And no matter how good of a job we do sampling, the odds of that sample looking like the population that we're addressing are not good. We can select a percentage value for constructing confidence intervals. So those tend to run anywhere from 99 down to 90%. Most of the ones that I see have 95% confidence intervals. These percentage values tell the researcher the percentage of randomly drawn samples from the population that contain the parameter mean, meaning if we did this over and over and over, 95%, for example, of the samples we took would actually look like what the population is. And that means that there's part of them that won't. So if we use a 99% confidence interval, if you draw any number of samples from the population, 99% of your samples within a band of percentages will include the population mean. If we set a 95% confidence interval, if you draw samples over and over and over, 95% of your samples with the confidence interval will include the population mean. Same thing with the 90%. It has to do if you keep doing the samples over and over and over again. And it does not mean that I'm 95% confident that my sample with these confidence intervals captures the population mean. That's not what it means. It means if you were to do it over and over and over, 90% of the samples in this case would include the population mean. So in essence, what's happening is this. Here's our population mean up here. So our first sample has a mean, but not every, a mean is an arithmetic average. So not everybody's going to have that score. Some people are going to be below, some are above. We take another sample. That one is still within a reasonable range, but the band of scores extends into different values. Here's another sample. It's got a slightly different mean and a range as well. So what happens is every once in a while, one of these samples gets outside of what we really consider the population mean. When you're using the mean as your statistic, the sample mean will be equidistant from the upper and lower limits of the confidence intervals. And when you hear that, you'd say, I don't have any idea what you're talking about. I'm going to show you a picture of this in just a second. It's generally seen as preferred to have a narrow confidence intervals with high levels of confidence associated with them. The larger the sample size, the larger the n, the smaller the confidence intervals. And these two numbers fluctuate with one another. So you'd say, I don't have any idea what you're talking about. So let's look at an example. Let's say in Wichita Falls, we conduct a survey and we simply ask them the question, do you prefer Coke or Pepsi? 60% answer Coke and 40% answer Pepsi. So an estimation of the population of the city is that 60% prefer Coke. So does that mean that 60% of the population of the city prefer Coke? No, not at all. We took a guess of the city based upon a sample that we have. We know that this probably isn't true. So if I was forcing you to make a decision about how many people like Coke, and I said that you've got to be fairly accurate, you would want to be given a little bit of leeway in terms of how accurate do I have to be. And things that control that has to do with how many people that you're allowed to sample. So if your survey is based upon 100 people, and we have a 90% confidence interval. The actual proportion of people who would like Coke would be somewhere between 52% and 68%. The average there is still 60%. Sample of 100 people, on average 60% of the people like Coke. We're 90% confident if we did another sample, between 52 and 68% of the people would indicate they like Coke. So again, we have a sample of 100. We said on average 60% of the people like Coke. And if we took samples over and over 90% of the time, somewhere between 52 and 68% of the people would say they like Coke. If I said, okay, you have to be more confident, you would want to be able to say, yes, I can be more confident, but you're going to have to give me more room in which to be confident. So if we increased our confidence level, we need more space in the range. So as an example, if we increased to a 99% confidence interval, meaning that if you were to take samples over and over and over, 99% of the time, what percentage of the people would say they like Coke? It would expand to 48% up to 72%. The average is still 60%. In other words, the software can be more confident, but you have to give it more room in which to be confident. So let's say if we wanted to make our sample look like the population and we started with 100, what could we do? Well, we get a bigger sample. All right, now I've got more people, and the more people I have, that changes some of the other values that I get from this. With the larger sample, we can go back to a 90% confidence interval, and it will narrow the range. So when we do that, we would say between 57.5% and 62.5% of the people like Coke. So go back up here. When we only had 100 people at a 90% confidence interval, we did samples over and over and over again. 90% of the time, we would say between 52 and 68% of the people like Coke. The average is still 60%. When I allowed you to have more people, and I put you back at a 95% confidence interval, because you have more people, that range narrowed. You came up 5.5 percentage points and dropped 5.5 percentage points. So now, by making your sample larger, you can be more confident in what you're saying. So what would happen if I said, okay, you have to go to 99% confidence interval? Well, you've got to give yourself a little more room. So here's what I want you to see what's happening. A confidence interval has either a 90, 95, or 99% value. And the range of the population based upon the sample mean varies. So with 100 people, I'm saying that the mean of the population is 68%, with the confidence intervals somewhere between 52 and 68%. If I did these samples over and over and over again, I would say that the mean is 60%, and then somewhere between 52 and 68% of the people like Coke in the actual population. If I told you got to be more sure here, then you're going to say, then you got to give me more room. That band is going to expand. Now, if I tell you can go to get a bigger sample, and so you don't have to be quite as sure, the mean for the population is still 60% based upon the sample you took. And you're going to tell me, well, actually the computer's going to say, okay, because we have more people and you've lowered my confidence level, I can be a little more sure about that value, and it's somewhere between here and here. If I told you have to be more sure, then you've got to have more room. So this number, and this number all work together. I want you to notice, though, this never changes. So this is really, the confidence interval is really a numerical value to describe how well your sample looks like the population. Ultimately, the larger this number gets, the smaller this number is going to get. and it can become more and more confident about the population. This is not something that you have to figure out, the computer figures out for you, but you'll read about confidence intervals in your reviews literature, and it's just something, it's just a concept that you need to pay attention to.